Let me start with adding and subtracting matrices and using scalars, and then in a separate video I'll talk to you about multiplication. But addition and subtraction, a couple things we need to keep in mind. First and foremost, whenever we add and subtract matrices, the dimension of the matrices have to be identical. This here is a 2-row by 3-column matrix. This here is a 2-row by 3-column matrix. Therefore, you can add these. Had I given you a problem that looked like this, you would say 2 by 3 and a 2 by 2. Remember, it's row by column. 2 by 3, 2 rows, 3 columns, 2 by 2. You cannot add these. Okay, you cannot add these two matrices because the dimensions are not the same. So on a quiz or a test, if you're given a problem like this, and I ask you to add or subtract, you say you can't. Term in the class we were using, you can write no way if you'd like. Okay, no way, can't do it. Come back up to here, 2 by 3 and a 2 by 3, yes, we can add this. And adding and subtracting, very similar, but basically you take each entry and the corresponding entry. So the 3 corresponds with the 2, okay, same position. So 3 plus 2 is 5. 5 plus 1 is 6. 1 plus 1 is 2. 2 plus 3 is 5. Negative 1 plus 2 is 1. And 0 plus 1 is 1. And that would be your answer. And subtraction works the same way. And what you just need to be careful of is negatives. Okay, so if I subtracted these two matrices, the first thing I'm checking, are they the same dimension? Yes, this is a 2 by 2, this is a 2 by 2. So I'm going to do negative 2 minus negative 1. Okay, negative 2 minus negative 1 is negative 1. Negative 2 minus 2, it's not 0, it's negative 4. Negative 2 minus 2, negative 4. Negative 3 minus 3, it's negative 6. Negative 7 minus 4 is minus 11. And you can use your calculator, but ultimately the most important thing is that you just keep track of your negatives and either add or subtract if the dimensions are the same. We can also use a scalar. So if I had a matrix and I had a scalar out front, the scalar is 5. A scalar is just a single number, a digit. I'm multiplying it times my matrix. Whenever you have a scalar, the scalar gets multiplied by each entry. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. And that would be your answer. And then the last thing is equal matrices. Two matrices are equal if their values in each corresponding entry are also identical. These two matrices are equal because 3, 3, 2, 2, 1, 1, 2, 2, they're identical. 3, 2, 1, 2, 3, 2, 1, 2. That means they're equal. So if I gave you something that looked like this, and I said solve for x and y, well, they're equal. X plus 7 has to be equal to 10. So x equals 3, and you'll just circle x equals 3. Because if x equals 3, 3 plus 7 is 10, 10 equals 10, 2 is 2, 1 is 1. Now I need y plus 7 has to be 13. So y is 6. So if I put y is 6 plus 7, 13 equals 13. So by virtue of the equal sign, every corresponding entry is the same. Hope that helps.